sixth one, divisibility by 9. What is the divisibility rule of 9? If the sum of all the digits of a number is exactly divisible by 9, then the number is exactly divisible by 9. In other words, if the digital root of a number is only 9, then the number is exactly divisible by 9. Every time I will consider this second rule only, but your wish, you may follow any rule. Once again, what is the second rule? If the digital root of a number is only 9, then the number is exactly divisible by 9. To understand this rule, let us see some examples here. First one, 531. Is this divisible by 9? 5 plus 3, 8, 9. So digital root is 9. So it is exactly divisible by 9. Next, is this divisible by 9? Let us calculate the digits. Let us sum the digits. 10, 19. 19 means 10. 10 means 1. So the digital root of a number is only 1. 1. So that's why this is not exactly divisible by 9. What we have to get to divide exactly the digital root of a number is only 9. The digital root of a number is only 9. Next, is this divisible by 9? We have to sum of the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So digital root is 9. So that's why this is exactly divisible by 9. So is this divisible by 9? We have already calculated the sum of the digits. How much? Have remembered? Yes, you remember. Very good. Keep it up. So sum of the digits is 45. But digital root is how much? Tell me. Yes, digital root. To get digital root, once again we have to add this 9. The digital root of this number is 9. So that's why this big number also exactly divisible by 9. So what is this number? You know already. How much this number? 98 crore 76 lakh 54,000 54,321 54,321. Next, 7, divisibility by 4. What is the divisibility rule of 4? If the last two digits from left is divisible by 4, then the number is exactly divisible by 4. If the last two digits means from left to right last. So these are the last two digits from left to right. Last two digits. In this, these are the last two digits. These are the last two digits. These are the last two digits. If this number, if this number is divisible by 4, then that this total number is exactly divisible by 4. We can check this. Is 12 divisible by 4? 4 3s are 12. 4 3s are 12. So this is exactly 12 is exactly divisible by 4. That's why this 9,812 is also exactly divisible by 4. Next is 1,214 is divisible by 4. To tell answer, we have to check these last two digits formed by the last two digits. 14. 4 3s are 12. So 2 is the remainder, not exactly divided. So that's why this 1214 is not exactly divisible by 4. 7836, is this divisible by 4? To tell answer, we have to test this last two digits. 36. 4 nines are 36. So 36 is exact divisible by 4. That's why this 7836 also exactly divisible by 4. Next, is this divisible by 4? We can check 94. 94. 4 2 is 8. 1 14. 4 3 is 12. So what is the remainder? 2 is the remainder. So that's why this 4494 is not exactly divisible by 4. Which digits are having in this ones to tens formed by the number ones to tens are last two digits having divisible by 4? There is a sequence. What is the sequence? I will tell you this sequence. By observing those sequence, we can say which is divisible, which is not divisible. If a number having the following digits in ones to tens places, then the number is exactly divisible by 4. What are the ones to tens digits we can see here? 0 0, 0 4, 0 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96. These are the last two digits. If a number has any of these digits in ones tens places, that number exactly divisible by 4. Example, here is a number 1 2 3 4 5 9 6. So this is the number 12,34,596. So is this divisible by 4? Yes, we can say, because here we have 96. So 96. One more number 78 76. Is this divisible by 4? Yes, 76. So here is the 76. So we can say like this. If you remember this sequence, if you remember these digits, you can identify easily. Next, 8, divisibility by 8. What is the divisibility rule of 8? If the last three digits of a number is exactly divisible by 8, then the number is exactly divisible by 8. Last three digits means left to right, last three digits. So these are the last three digits. These are the last three digits from left to right. Last three digits. If this is divisible by 8, then this total number also exactly divisible by 8. Let us see which are exactly divisible by 8. So 416 we have to check. 8 5 is 40. 1 bring down 6. 8 2 is 16. So we got 0. So this number is 416 is exact divisible by 8. So that's why this total number also exact divisible by 8. Next, is this divisible by 8? We can check. 188. We have to check 188. 8 2 is 16. 2 bring down this 8. 8 3 is 24. So what is the remainder? 4 is the remainder. So that's why this number is not exactly divisible by 8. So next 67,000. Is this divisible by 8? We can check. Zeros. Here we have zeros. Zeros means this 3 zeros means what? We can take 1 0. If 0 is divided by any, 0 is divisible by every number. 0 is exactly divisible by every number. So 0 by 8 is equal to 0. Or we can divide 8 zeros are 0. So if there are 3 zeros in ones, tens, hundreds places, ones, tens, hundreds places, ones, tens, hundreds places, then the number is exactly divisible by 8. Next, ninth, divisibility by 11. What is the divisibility rule of 11? If the difference of sums of alternate digits is 0 or multiple of 11, then the number is exactly divisible by 11. In other words, if the sum of digits in odd places and the sum of digits in even places in a number are equal, or difference of sums is multiple of 11, then the number is exactly divisible by 11. So first rule is the best. What is the first rule? The difference of sums of alternate digits is 0 or multiple of 11, then the number is exactly divisible by 11. To understand this rule, we have here some examples. Here we have few examples. How to identify sum of alternate digits? We have to calculate first sum of alternate digits. 9 plus 7 16, 16 plus 0 16, 16 plus 3 19, 19 plus 1 20. So this is 20. Sum of these alternate digits is 20. Another alternate digits, 8 plus 6 14, 14 plus 4 18, 18 plus 2 20. These also 20. The difference of these sums is 20 minus 20 is equal to 0. So that's why this number, what is this number? 12 crore 34 lakhs 6,789 is exactly divisible by 11. If there is a doubt, you may check, you may do actual division. There will be 0. Next, second, is this divisible by 11? We can check. 2 plus 0, 2, 2. Here also 2. Oh, sorry, 2. Next alternate. 7 plus 8, 15. 15 plus 9, 15 plus 9, 24. 24. So the difference of these sums is 24 minus 2 is equal to 22. Is this divisible by 11? Yes, this is divisible. How can we say 22 is the multiple of 11? So that's why this number 9,08,072 is also exact divisible by 11. Next, third one, is this divisible by 11? We can check. 6 4 plus 4 10, 10 plus 2 12, so 12. Next, 5 plus 3 8, 8 plus 1 9. The difference of these numbers 12 minus 9 3. So is this divisible by 11? No. We aren't getting here 0 or multiple of 11. That's why this is not divisible by 11. This number means 1,23,456 is not exactly divisible by 11. Next, here we have fourth problem. 9, 9, 9. How many nines? 1, 2, 3, 4 nines. 4 nines. 4 nines are 36. Next alternate. 2 plus 1, 3. 3 plus 0, 3. So how much? 3. The difference of these sums is 36 minus 3. How much? 36 minus 3. 33. Is this divisible by 11? Yes. This is exactly divisible by 11. So why? 33 is the multiple of 11. 11 3 is a 33. So that's why it is exactly divisible by 11. At the beginning of the class, I gave you a question. I gave you a challenging question. Are you solved? If you have solved, you may check your answer. What is this number? 987 crore 65 lakh 43,120. So is this divisible by 10? Is this divisible by 10? Yes. Here we have 0. So this is divisible by 10. So is this divisible by 5? Here we have 0 in units place or ones place or units place. Here we have 0. So that's why this is divisible by 5. Next, is this divisible by 2? Yes, it is even number. This is exactly divisible by 2. Next, is this divisible by 3? How to identify? We have to find the digital root. If the digital root of a number is 3 or 6 or 9, then the number is exactly divisible by 3. So digital root we know already. So in this, what are all digits? We have all digits. Sum of the all digits is how much? We have already calculated. 45. How much? 45. So 45, 2-digit number. So again we have to add. What is the sum of these digits? 9. So digital root how much? Digital root is 9. So that's why this is number is exactly divisible by 3 also. Exactly divisible by 3. Next, is this divisible by 6? Yes. Why? Because if a number is divisible by 2 and 3, then the number is exactly divisible by 6. So that's why it is exactly divisible by 6. Next, is this divisible by 4? Yes. In that I gave a sequence. In that sequence we have these digits 2 0 20. 4 5 is 20. So that's why it is exactly divisible by 4. Is this divisible by 8? So how to identify last 3 digits? We have to check last 3 digits. 120. 120 we have to divide. 8 ones are 8. 4. Bring down this 0. 8 5s are 40. So this is exactly divisible by 8. So is this divisible by 11? We can check. We can add alternate digits. We can add alternate digits. Sum of alternate digits. Alternate digits. 0 plus 1, 1. 1 plus 4, 5. 6 plus 6, 11. 11 plus 8, 9, 10. 2 plus 3, 5. 5 plus 5, 10. 10 plus 7, 17. 17 plus 9, 26. How much is here? 26. The difference of these digits 26 minus 19. How much? 16 minus 9, 7. 7. So this is not equal to 0. This is not a multiple of 11. So that's why this is not exactly divisible by 11. Except 11, all numbers 10, 5, 2, 3, 6, 4, 8. exactly divisible this number. Thank you for watching this video. Please like and share. If you haven't subscribed my channel, immediately subscribe to get more and more videos. Here is an important note. The note is, if two co-prime numbers are factors of a number, their product is also a factor of the number. Divisibility by 12. If a number is divisible by 3 and 4, then the number is divisible by 12. If a number is divisible by 3 and 4, then the number is exactly divisible by 12. To understand this, I am taking an example here. Here is 24. Here is the number 24. 24 is divisible by 3. 3 8 the 20. 3. 2 plus 4 6. So that's why it is divisible by 3. And 24. The last two. If the last two digits of a number is exactly divisible by 4, then the number is exactly divisible by 4. So that's why it is divisible by 4 also. These two are co-primes. Co-primes means what? If two numbers have no common factors except one, then the numbers are called co-primes. So these two are co-primes. Their product what? Their product what? 3 4s are 12. So 12 also divide the number 24 exactly. This 12 also divide the number 24 exactly. 12 2s are 24. Similarly, we can take one more example. 36. 36. So it is divisible by 3 plus 6. 3 plus 6, 9. Digital root to 9. So digital root of a number is 3 or 6 or 9, then the number is exactly divisible by 3. So it is divisible by 3. And 36. I told you to the sequence which numbers are divisible. 0 0 0 4 0 8 12 16 like that. So if you didn't remember, you may divide these two numbers. 4 9s are 36. So that's why this is divisible by 4. These two are co-primes. So their product is 3 4s are 12. Divide the given number 36 exactly. So this 36 also divisible by 12. So this is the concept. What the concept of if two co-prime numbers are factors of a number, their product 3 4s are 12 is also a factor of the number. Second example. This is one example. This second example. 36 is a factor of 36. Factors of 36 3 4. Their products 3 4s are 12. So 12 is also divide the 36. So that's why 12 is also factor of 36. To understand the note, I am giving one more example here. If a number is divisible by 3 and 6, then the number is may or may not be divisible by 18. So why may or may not be divisible by 18? Here 3 and 6 are not co-primes. Factors of 3 are 1 3. Factors of 6 are 1 2 3 6. Common factors are 1 3. So that's why 3 and 6 are not co-primes. That's why their product 3 6 are 18 may or may not divide the given number exactly. To understand this clearly, I am taking an example here. Here is 24. 24 is divisible by, exactly divisible by 3. Why? So digital root of this number is 2 plus 4, 6. digital root is 6. So that's why it is divisible by 3. And also divisible by 6. Why? So it is divisible by 2, even number. It is also divisible by 3. So digital root we got 6. So that's why it is divisible by 6. 24 is divisible by 3 and 6. Is this divisible by 18? No, it is not divisible by 18. 24 isn't divisible by 18. 18 1 the 18. So 14 minus 8, 6. So that's why if a number is divisible by 3 and 6, then the number is may or may not be divisible by 18. When it is possible, these must be co-primes. These must be co-primes. Then only divisible by their product. Similarly, we can say some more here like that. Next, 15. If a number is divisible by 3 and 5, then the number is exactly divisible by 15. 3 and 5. Next, 18. If a number is exactly divisible by 2 and 9, then the number is exactly divisible by 18. Next, 24. If a number is exactly divisible by 3 and 8, then the number is exactly divisible by 24. 3 8 is 24. Next, 40. If a number is exactly divisible by 5 and 8, then the number is exactly divisible by 40. So like this we can understood.